Physics, chapter 25, theory video 6. So now in modern day, we know a lot of things about electrons and how electricity is generated and how electricity flows, but this was not actually that apparent earlier on. So in the 19th century, people, the scientists were trying really hard to figure out how the charges flow. And J.J. Thomson, the physicist J.J. Thomson, is one of the pioneers of modern day physics, and he is the one who discovered electrons, and he used this deflection tube in discovering that. So this is actually his tube was his vacuum tube was quite similar to the one that we learned earlier. At one point there was an electron gun, and this is called which were known as cathode rays. Now you must remember from in O levels we use the same term. Then we used two, you can remember this experiment we have studied. There were two metal plates to apply electric field to deflect the beam. Then he placed the magnets outside the tube to, force the electrons to change their direction. So he observed that the beam would get deflected towards the positive plate away from the negative plate. So he deduced that the particles should have a negative charge, right? Then this was also confirmed because of the deflection of the beam by a magnetic field. So when the beam was deflected, then he suggested when this beam gets deflected, they don't actually they remain as a beam. So that meant that the beam consisted of particles with the same mass and charge, and also by speed, because if they were if their charges were different, they would get deflected less or more depending on the charge. Then if it had higher speed, it would also get deflected in a different way, and also the mass also would be the same. That means the heavier ones would get deflected more. So then he used both electric and magnetic fields. He used the both magnetic field to balance this beam to remain straight in the horizontal axis. Then he calculated the charge to mass ratio E upon me for these particles. He did not know the values for E or me because it was still under investigation. But he concluded these particles were very much lighter than the atoms. Initially, he thought that all the atoms were made up of electrons, but we know that it is a combination of negatively and positively charged in a neutral environment. The charge of the electron, as you know, 1.6 × 10 to the power minus 19 coulomb, is extremely difficult to measure. But it was Robert Millikan who did this, who actually found a better way of doing it. Now he took a single. He actually observed electrically charged drops of oil, and he realized that all of these charges have a integer multiple of a single value. So then he combined this with E upon me and then found out the mass of the electron. So that is not something that you need to know, but you need to know how to do the calculation, right? So that question 10 would give you the idea how to do the calculation. So if you have any doubts, please ask me questions. If you do not have any doubts, please go to the end of chapter questions. So there are many equations that we have learned here. F equals BQV, then F equals BQV sine theta depending on the angle that it is acting on. BEV equals mE squared upon R, V equals E upon B, and the whole equation, whole voltage equation. So all of these things we have discussed. Then this part, VH is directly proportional to magnetic flux density B. Then VH is directly proportional to the current. However, it is inversely proportional to the number density simple n and thickness of the slice simple t. VH is directly proportional to B because the current in the slice is constant. That is also something that you need to understand. Please read through the summary also. If you have any questions, please raise them. If not, please do the end of chapter questions to see whether you have understood them more.